My name is Adrie Wisman, and this is the walkthrough of our proof of concept of the self-sovereign attendancy application, which we wrote for Node.js and JavaScript for the IOTA Tangle Chrysalis version, and with masked authenticated messaging version 0, which we are going to interchange for streams before deployment. Now, by now I presume you have found our Git, where all our code is. You use the instructions to clone, run npm install, and go into the code directory, where you can see these 5 JavaScript programs: organizer, attendee, generate QR, event close, and verifier.js. I will walk you through all these different programs and how they function. Let me first show you how the initial state is. And for that, I'm going to go back to the sheet. Here you see 2 phones, 2 wallets. The attendee wallet, which has some personal information about the attendee, and the organizer wallet, which has information about the organizer and the events he organizes. The information on the attendee wallet will never leave his phone, and he can, if he really wants to, share some personal information, but only on his explicit request. Now, the organizer has to initialize the event, right? And he does that with 3 transactions. First, he will initialize the MEM, the MEM channel. He will write some primary private information about the event, which also has, for instance, the private key of the event. Then he writes a second record, which has public event information, which says, okay, time and date and location of the event and who organizes it, and the public event key. And then he will write a secret to the tangle. With this secret, the attendee can find the event information, and he finds the address where he can register for the event. That is done by a QR code, which you can put on a sheet, on a slide of your presentation, or we're working on it that you can use a Bluetooth beacon, which the attendee phone can scan in the room and receive the key. So with that information, he knows where to register, on which indexation he has to register on the tangle for this event. Now, I'll show you how that works. I'll go back to the code, and we see here the organizer, attendee, event close, generate QR, and verifier code. In the organizer code, you can see I hard-coded some information about the organizer and some about the event. Normally, this would not be hard-coded. This is for demo purposes. So this would be on the phone of the organizer. It's a variable in his wallet. We're going to initialize the event. So in the directory code, I will do node organizer. Then he asks me for the event seed. This is an 81 character long master password for this event, so to speak. Right? I can type in 81 characters, or I can put in a star, and then he will randomly generate a key for me. Then he asks me for a secure organizer key. This is also 81 characters long. It is the side key for the MEM channel. This is a restricted MEM channel, so everything is encrypted with this 81 character long side key, but the private record, the first record we write, could have a separate, different side key, temporarily only for the first record. Now, it's not really necessary, and maybe you know it, but a MEM channel, the records in that list can only be found one direction. You can only go from the first record, and there you find the address of the second record. You can never go back. Right? So it's not really necessary, but you can. I will put in a star because I will not change the side key for this first record. That would make my demo a lot more complex, but you know you could make a double encryption out of that. Okay, now he registers the event on the tangle. And you can see here, for instance, that 81 character randomly generated seed. You can see the 81 character long side key of the MEM. Here you can see the private and public event keys that were generated. And this is elliptic key encryption, so the private key is shorter than the public key. He writes the first record to the MEM, and he writes that on this message ID. This is a lot of information. I've just put it there for demo purposes so you can find it. I will copy this and I will show you where to find it. If I put that in the Explorer and go to Chrysalis testnet and search, here you can find the information. Now, you cannot read it, right, because it is encrypted. But I've also put in a link which incorporated that 81 character side key. I'll copy that, paste that in, and then we can look into there. Because now here I have the 81 character long side key. I've chosen that the first record is with the same side key as the rest. Like I said, you could use a different one. Here you can see the first record with the title, a timestamp, and the private key for this event. And here you can see the second record of the MEM with the organizer information, name, address, city, telephone number, website URL, etc. And here you can see the event information, the title, even date, time, location, etc. And here you can see the event public key. Now I will leave this MEM channel open on screen because later on we will append the attendee list, the official attendee list, and we will close this channel so nobody can append any attendees later on. And you can see that in real time. So on this screen you can also see the attendee QR code. This is the QR code that you will show in your presentation. I can copy this and paste it in my Explorer. So this QR code is the link for your attendee. By scanning this QR code, he can find the public event information and he knows where to register for this event. This QR code also has an expiration time and date. I've set this to 20 minutes. After 20 minutes, this QR code is unusable. You cannot use it to register for the event anymore. Even if the host has not closed the event, you can not use this QR code. I've put it on an expiration time at this moment, but you can also use it and change it in the code. So you could say, hey, the event host already makes preparations for his presentation and says, okay, the QR code should expire tomorrow afternoon. I'll start my presentation at 4, so the expiration should be at 4:30, for instance. All this information is in that QR code, and it is very hard to tamper with. Here we see some other information, but I think this is information you already saw. This is the information that is put into the second record of the MEM. Now let's register an attendee. Right, I'll type in node attendee.js, and that's this code. And in this code, you can see the information of the attendee. It was hard-coded for demo purposes, but normally this would be retrieved from the phone of the attendee. It's a variable, and this information is changeable by the attendee, of course. This information will generate a Merkle tree and a Merkle root. I didn't do that in this demo. I just put in a hash, and by changing this hash, I can change into a new attendee. We'll do that. I will first register this attendee. So he says, okay, I see this QR code. Now, in this demo, I did not scan with my phone. I just wrote this QR code into a file, and this attendee.js reads that file and says, do you want to use that QR code? Yes, I do. Type star. And now he uses that QR code to fetch the public event information from the Tangle. He says, okay, first this QR code will expire then and then. This is the event that you are currently on, and it is organized by that organization, that street, that city, that telephone number, etc. Would you like to register for this event? Yes. And now I can put in an optional remark. I can leave it blank, but the organizer could say, well, put in the city where you live. I'll put in Amsterdam. There's 1 million people living there, so this is not personal information. And this information, this remark, will be stripped. It will not be incorporated into the official attendee list. But as you can see in a moment, the organizer can real-time see who is registering. And so he can see, oh, the people from Amsterdam registered, and from Gothenburg, and from Antwerp. That's going nice. Well, he's not the only one that is registering. Let's say somebody else registers. I'll change the Merkle route here. I'll change that into 7, for instance. And I'll register a new person. With that QR code? Yes, with that QR code. Do you want to register to this event? Yes, I want to register. Optional remark, student 8135. Schools could use this. And that person is being registered to this event. Let's say this student registers twice. He scans the QR code again, registers one more time. Do you want to attend? Yes. Optional remark, blah, blah. And he registers. Okay, this person registered and the registration is going on. The host can see that in real time. I'll type in node event close.js. He says, okay, you're working with this event. And you're the organizer. The registration is still open. And here you have a menu. You can type T for Tangle List, D for Detailed Tangle List, C for Close, or Q for Quit. Now, T for Tangle List shows you all the transactions which occurred on that special address. And you can see there were 3 transactions. Totally, the sum is 3 transactions. But I'm the host, I'm the organizer. So I also have the private key with which these messages were encrypted. And I'll show you a message like that. I can copy this and go to the Explorer, the Tangle Explorer. I'll paste in this message ID and look into it. Here you can see what is stored into a attendee transaction. This. Now this is encrypted with the public event key, which is an elliptic curve encryption. And for people who know what that means, that's comparable to RSA 3072, which is a military grade encryption. So good luck if you want to look inside. But I am the host. I have the private key. So I can type detailed tangle list, D, and look inside these transactions. And here I can see inside this transaction, this is the attendee token, this is the remark, and this is the timestamp of that message. I also see, this is student 8135, somebody did a double transaction. And he sees that this attendee token is used twice. Every person has a unique attendee token, which is a combination of personal information, public information for this event, and it's designed in a way that it is unique. So everybody gets a different token for different events. You cannot use this for inference or singling out people. You cannot say, oh, that guy was at event A, B, and C. This should be that guy. Impossible. Okay, this is a double ID. So there are 3 transactions, but there are only 2 unique IDs. Right? And like I said, this is real time. So I can quit out of this program and register somebody else. Right? I can go and put in a different Merkle route, save that, and register another person. Use that QR code? Yes, I use that QR code. Do you want to attend this event? Yes, I want to. Optional remark, X, Y, Z. And that person is registered. If I go and look as a host, and I'll press, the event registration is still open. Press T for a tangle list. Now I see 4 transactions. Right, 4. I can even go and look into the transactions, detailed tangle list, and I see this guy, XYZ, also registered. So in real time, I can see who is registering at the moment. Now, let's say I close the event. Right, I see that all people who are attending have registered, and I press C. And now we can go and look on the tangle into that MAM channel, and he will write the official attendee list to that MAM channel. And here you can see them in real time. These 3 attendee tokens have attended the event. Right, and now he's writing the closing message. So nobody can change anything on that list. Okay, we're waiting for that. Attaching closing message to Tangle. And this is the proof of work. Now he's done. And here is the closing message. He also says it here. Event closed by the organizer. And now there's no more C. There is an A for attendee list, because now I can ask for the official list. And this is the official list with the 3 attendee tokens for the 3 official attendees. Okay, I'll quit this. Now, an attendee can go to a verifier and say, well, I attended that event, right? So that's this situation. This situation, the attendee wants to show the verifier QR code, and in that QR code there is, amongst other things, a pointer to the public event information and the official attendee list, so the verifier can check if the information that is included in this QR code is on the attendee list and tell if the person was at that event, yes or no. Let's do that. I will go to generate QR node, generate QR.js. Is it okay? Would you like to incorporate your name and birth date? There are 2 ways you can make a QR code in this program. You can make it anonymously, which only shows an attendee token, and the verifier can see if it's on the list, yes or no. Or you can even, if the verifier requires it, says everybody can show me that QR code, I want to see which name and which birth date is attached to that attendee token. And then you can incorporate that also. I will show you both. I will do first your anonymous way. So I don't want to incorporate it. And he says, okay, this is your verifier QR code. And I put in a link for demo purposes, which you can copy and paste into your browser. So this is the QR code that you have to show the verifier, and then he can see if it is okay or not. We'll do that. Node verifier.js. Okay, do you want to use this verification QR code? Yeah, and that's the same as this one, right? Yes, I want to check this one. Yes, okay. This QR code was generated at this time, 0 minutes ago, less than a minute ago. right? Because here you can see that if the QR code is older than 5 minutes or, right, then from yesterday, somebody could have a picture of the QR code of his friend that was at this event. Then the attendee, the verifier would say, well, please generate a new QR code and even incorporate your personal information. So I'm sure that it was you. Here the verifier can see which event it was and organized by whom, telephone numbers, email addresses, etc. The event was closed at that time and no personal information was included in this QR code, but this attendee token is from somebody who has attended the event. Right? I will generate the same QR code now with personal information. Yes, I would like to incorporate that. Yes, okay, this is your new QR code and it has another link. I will copy that and paste that also. You can see that it is a little bit different. There's a little bit more information also in there, because now if the verifier looks at that QR code, he says it was generated 0 minutes ago for that event organized by that firm. The event was closed then. And this is the personal information of Robert Smith, birthday that and that. With this attendee token, he has attended this event. Right, so this person is on the list. Now I'm gonna speed things up a little bit because I know that the QR code has not yet expired. So somebody is going to sneak in. I'm going to go to node attendee. I'll generate a new Merkle root. Let's say 0 at that point. And this guy use that QR code. Yes, use that QR code. It's from this event. Would you like to register for this event? Now, remember, the event was closed, but the QR code has not yet expired, right? So it's still usable. So would you like to register? Yes. Optional remark, Berlin. Writing attendancy to the tangle and done. Right, so the QR code was still not expired. He could do the transaction, although the organizer has closed the event. Let's look. Node event close. The host can look into that. Yeah, it says, hey, the event was closed at that time. What would you want to see? I want to see a tangle list. And now he sees 5 transactions. Right, I can even look into them, detailed tangle list. Right, and here is the guy from Berlin. He tries to sneak in, but the event is already closed. The tangle has already got a record of the 3 people who officially attended the event, right? You cannot sneak in. If I put in attendee list, I get these 3 people. The event was closed at that time, and these 3 are the official ones that attended the event. That person from Berlin cannot get on the official list. Right, so if I quit out of there and I go to verifier, I'll try to generate a QR code. Would you like to incorporate information? No. I'll verify this guy from Berlin. Do you want to use that QR code from him? Yes. And he says, no, this person was not registered at this event. Right? So, like I said, he was able to do a transaction, but he could not get on the official list, and so he was not registered at the event. That's the immutability of the tangle working for us, and now he's unable to sneak in. But the QR code was still valid, right? So let's see if the QR code has expired already. We'll try another Merkle hash in there, and we'll just try to put in a new attendee. Let's see if we can do that. Use that QR code. Yes, use that QR code. Now, this QR code has expired, right? So after 20 minutes or after a certain time and date, which the organizer has set, this QR code does not register anymore, right? So there are several mechanisms, and even if you would do a trick with your time on your phone or whatever, the event is closed. You cannot change the official attendee list. So this is a quick walkthrough, and you see the code, and it's still a bit rough. All right, it's meant as a starting point. It has lots of remarks and lots of console logs in there, so you can see what is going on. It is meant, like I said, like a starting point for your own code. There's lots of things to refactor. I think at least 30% of the code is remarks, etc. So have fun with it. It's just a proof of concept, and now we are going to build this into a React Native app, so everybody can use this on his or her phone. It's an open source project from Interreg Project Bling, Blockchain in Government, for which we are building this. So if you have any questions, you can find us through our website or through our GitHub. Don't hesitate to contact us, or if you want to cooperate with us in any way. And I would say happy and fun times in building your own application for a self-sovereign attendancy, so people can register at your event and prove they were really there. Good luck.